Okay, so
Right, sir.
if you remember, we started with the uh, primary memory, uh, and then in this primary memory, we already discussed about this SRAM and DRAM, and in this SRAM section, we already discussed about the cache memory and the registers. Okay.
Yes, sir.
In the previous. So topic for the today is this dynamic RAM and ROM complete this part. So today we finish this primary memory section. Okay.
All right.
Let me move to the second slide. So topic for the today is main memory, read-only memory, and storage unit hierarchy. Okay, so this is from the previous slides because we are dealing with the RAM section. So for the review, what is random access memory? In the earlier section, I already told you that RAM supports random access. And what is the meaning of random access?
Means to pull the information randomly instead of in sequential.
Yes. And if you access anything from any location, it takes the same amount of the time. You are taking something from this place or this place, it takes the same amount of the time. Okay, that's the important thing. Okay. Okay, RAM is divided into the two types: SRAM, that is static RAM, and DRAM, dynamic RAM or dynamic random access memory, and static random access memory. Okay, read and write can be performed in any order, and it takes same amount of the time. Okay. Please be careful here. I am not saying that reading time is equal to writing time. I'm not saying this thing. Okay. I am just saying that reading time from any two location is same and writing time at any two location is same. I am not saying that reading time is equal to writing time. Okay.
So, I understand.
Yeah, reading time is not equal to writing time. Writing takes some more time, but reading from two locations is the same, and writing time from the two locations is also the same. Okay. RAM is an volatile memory as the data lost when the power is turned off. Okay. Then in SRAM, which we already finished, is cache and register section, cache and register types of the memory. Okay. It uses the transistors, especially 6 transistors, to store a 1 bit. It is more expensive, it is faster, it consumes less power, and hold contents as long as power is available, means no charging required. Okay.
Yes, sir.
And in DRAM or dynamic RAM, a bit of data is stored using one transistor and one capacitor. See, this capacitor is the reason why you need charging. Okay. This capacitor here, this capacitor is the reason why you requires recharge after every few milliseconds to maintain its data. The reason is the using of the capacitor. But what it do? It make it less expensive. But again, this comes it's a slow memory again. Okay, because you need a charging at every short interval of the time. Okay, that make it slow. Okay, this is often used as the main memory, and this is known as also a RAM. See this difference here. This is a RAM. Okay, a type of random access memory. Okay. Okay.
Oh, yes, sir. Yes, sir.
Okay. Okay. So what is main memory? Main memory is a dynamic random access memory. Okay. For the clarity here, main memory is in the CPU is known as RAM. Okay. But I'm not using this term RAM because it makes it confusing. Okay. I'm just saying that this main memory or RAM is a type of dynamic random access memory. Okay. Or main memory. So I am not going to use RAM anymore. I'm just saying that it's a main memory. Okay. To make it more clear. So main memory stores data and instructions during the execution of the program. You already know what is the size of register. It's 32-bit to 64-bit. Yes or no?
Yes.
And what is the size of cache memory? 2 megabyte to 16 or 16 megabyte. The basic depends on L1, L2 or L3 cache.
Yeah.
It's again a small memory, because if you ever install your Microsoft Office, the size of Microsoft Office is around 2 gigabyte. So you can't store this Office program inside your cache memory. Next one is this, your main memory or RAM. What is the size of your RAM? It's around 4 gigabyte to 8 gigabyte, or some maybe 32 gigabyte. It may be anywhere between 4 to 32 gigabyte in modern system. Okay, so this here RAM, it stores your all the programs, stores data and instruction during the execution of the program, and this data is lost when the power is gone. Main memory provides a limited access storage capacity due to its high cost. Again, okay, suppose you have a 4 or 1 DVD. 1 DVD size of 1 DVD is around 4 gigabytes. 1 DVD contains 1 or 2 movie. Suppose you have 100 movie. You can't store these things in RAM. You have a hard disk. Okay, because hard disk provide you cheaper. Its cost is less of hard disk, and it provide you larger storage capacity. Okay.
Yeah.
So main memory provides a limited access storage capacity due to its high cost. High cost in terms of what? Not register and cache. Register and cache are still more high, have more cost. Okay. It is cheaper in comparison to hard disk. Sorry, it is its cost is high in comparison to hard disk, but its cost is less in comparison to your register or cache memory. Okay.
But cost as in the price of it, or
Yes, in terms of price, in terms of the price.
All right.
Okay.
Yeah.
Okay. So main memory stores the data when the computer is on. When you turn on the computer, the data moves from your hard disk to your RAM. Okay. In the beginning. So therefore you need a hard disk, because once you turn off the computer, data is no more in the RAM. It must be written to the hard disk. Okay.
Yeah.
So this okay, I'm coming on this later. Information stored in main memory is get erased when the computer is turned off. Once you turn off the computer, data is gone from the RAM. Okay. And again, one more thing, main memory is semiconductor memory, or means, see, in earlier section in DRAM, I told you it consists of one transistor. Okay. And transistor is known as a semiconductor device. Okay. This is coming from the electronics. Okay. So transistor is a semiconductor device. Because the main memory has the same transistor, it is known as a semiconductor memory.
Semiconductor.
Yeah. Okay. So sometimes what happens when it's suggested that please don't turn off your computer immediately by using the power button. Why?
Because the information can be lost.
Yes, because once you turn off the computer, go in the start memory and then click on the turn off button, any data inside your RAM is written to your hard disk. Okay. And then your computer goes in the shutdown mode. But if you just use the power button to turn off your computer, this process, writing data from RAM to the hard disk, is not completed. And it may corrupt your data. Maybe some file goes to, means if you try to read it again, you're not able to read this file again because it is corrupted. Okay.
Yes, sir.
Okay. This is the RAM. So normally, normally your this is the hierarchy of your memory. You have the CPU. Inside the CPU, you have the register and cache memory. Okay, this is inside the CPU chip, and then you have a RAM memory. Okay, these things are coming inside the primary memory. One more memory left, that is ROM. What is ROM? That is known as read-only memory. Okay, and this read-only memory is the first memory. Once you turn on your computer, your CPU start accessing the read-only memory the first. Okay, this is the small amount of the memory. Okay, ROM is the primary memory unit of any computer system. Okay, ROM stores binary information permanently. So either you turn off your computer or not, the data is always in a safe position. Okay, data is not going to be removed. Okay, it is always there. Information is embedded in the ROM in the form of a bit by a process known as programming the ROM. So once you, how you write the data inside the ROM? Answer is you can't write. Okay, it is written by some special device, some special programs. Data is in the form of bit. Okay, and to write the data inside your ROM chip is known as the programming the ROM. Okay.
Yes, sir.
Okay. In the next slide, I am going in deep. What is the meaning of this programming the ROM? But remember, this programming the ROM means writing the data inside your ROM. Okay.
Yes, sir.
Good. So these ROM devices are of 4 types: PROM, EPROM, EEPROM, and Flash-ROM. Okay, Marky, what is the difference between RAM and ROM? Okay, once you turn off your computer, data is no more inside the RAM. Okay, but once you turn off the computer, data persists inside the ROM. So either you turn off or power is gone or anything happened with your system, the data is always there. So data always there. Okay, and here once power off, data is gone. Okay.
Yes, sir.
So next slide, I'm going deep with PROM and EPROM. Okay. So what is PROM? So PROM stands for programmable read-only memory. Okay. Again, what is the meaning of program here? To write something inside your ROM. That is the meaning of program. Okay. So in PROM, you can write something inside your ROM, but see here, this first prepared as blank memory. So in the beginning, this PROM is just a blank memory. Okay. And then
Yes, sir.
program to store information. How you write program? The process of programming the ROM, programming the PROM is called the burning the PROM. Okay, this is known as burning the PROM. So writing inside some in PROM is known as burning the PROM. Okay. Okay. Once you burn your PROM, means write the data inside your PROM, you never can change this data. Okay. Data stored is, it cannot be modified. So it is called a one-time programmable device. So only one time you can write the data, and once you write something inside the PROM, you can't change that particular data. Okay.
Yes, sir.
What is the applications? It is used inside your cell phones, video game, RFID tags, medical devices, and other electronic devices, equipments. Okay. Basically anywhere where you just write a one-time program, that's the PROM. Okay. But what is the problem with the PROM? Suppose today you write this program here. After some time you want to modify this. You can't do that thing. You have to replace this PROM chip. That's the only solution. Okay.
Yes, sir.
So This is the only problem with the PROM. So we move to the EPROM. What is EPROM? It is erasable, programmable, read-only memory. Okay. So here, after writing a program once, you write one time, then you can erase it. Okay. It again goes to empty, and then you can write again your program. Okay. That is the solution come in the EPROM. But how you can erase it? It is using the special UV light. Okay, here EPROM is placed under a special ultraviolet light for a length of a time. The short wave radiation make the EPROM return to its initial state, which then can be programmed accordingly. Okay, so you write in EPROM at one time. If you want to write it again, put it in some ultraviolet light. After some time, this EPROM go in its initial state, and then you can again write. Okay.
So, sir, like other than the UV light, could the information be erased anywhere else with any other process?
Not in EPROM. For EPROM, you require the ultraviolet light, UV light. Okay.
Alright.
Okay. To erase anything from the EPROM, you need the UV light. Okay. Next thing. So this is the only problem.
Yes.
UV light is required to erase something from the EPROM, and the solution comes. Okay. To write something in the PROM, a PROM burner is used. Okay. So this is a special kind of device that can erase thing and then you can write. Okay. So you just ask, sir, I need UV light, but this is the problem for a normal programmer. Then solution comes in the form of EEPROM. Okay. So earlier it's just a PROM, that is programmable ROM. Then it's erasable programmable ROM, and then one more E comes, that is electrically erasable programmable read-only memory. Okay. So to remove the content, so it's just a EPROM. So it's just a EPROM plus, instead of UV not required, it's just a electrical. Okay. So here you don't need the UV rays. You have just electrical signals that can erase the things. Okay.
Yes, sir.
Similar to EPROM, except that the EEPROM is returned to its initial state by application of an electrical signal in place of ultraviolet light, and that makes the things easy. Okay. Now, it is similar to EPROM, except that EEPROM is returned to its initial state by the application of electrical signal in place of, I think this is just a repeated thing. So this is the same thing. It erases or write one byte of data at a time. See this point. This is the important point. Okay. This point is important. In EPROM, you can write or erase only one byte of data at a time. Okay. So if you have, see here, suppose you have here 10 okay, 10 byte of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what is the meaning of this one? It is of 8 bit or 1 byte of data. So you can erase this byte of data and write here something. You can erase this byte of data, then you can write here. You can erase 1 byte of data. Okay. So you to write or erase something, you go to byte by byte. Okay. Getting the things? So in EPROM, you have to remove or write a byte of data at a time. So if you have 10 byte of data, you have to repeat the process of erasing or writing 10 times. Okay. So that make the EEPROM slow. Okay. Getting the thing?
sir. Continue.
Mhm. Difficult?
Yes, sir, I'm getting it. Yeah. One byte of data at a time in order for write another byte of data. So that is
Yes.
why it's slow.
Yeah. So it is used for storing the computer system BIOS. So you are me in the future class I discuss about this BIOS, that is basic input output system. Okay. When you start your computer, this BIOS is load first. So that BIOS is written in the EEPROM. Okay.
Yes, sir.
Okay. Then so this is the only problem here. Byte by byte, that's the problem. Solution comes in the Flash-ROM. What is Flash-ROM? It is just the enhanced version of the EEPROM. What is the solution? In EEPROM, only 1 byte of data can be deleted or written at a particular time. Whereas in Flash memory, a block of data, generally 512 bytes, okay, can be deleted or written at a particular point of the time. Okay. And this Flash-ROM is used as a
So by
BIOS or modem. Yes.
so when you mean by a particular time, I mean like at one time or like
At one time. At one time.
at one time, right?
Yes. So if I want to summarize this ROM set, this ROM is divided into what is known as PROM, EPROM,
You,
EEPROM, and Flash-ROM. Okay. So what is the problem with PROM? Write once,
you could write data, but you can't
write
erase it.
yes, write once and then no more. Just write once. That's the problem. Solution in EPROM, you can erase and write any amount of them time. Okay, in loop, you can write and then erase, write and then erase any amount of the time. You can repeat this process. Okay, but it requires ultraviolet light. Okay, UV rays. This is the problem. Solution comes here, erase and write again and again. Okay, but here you no more UV rays no more required. You will just need an electrical signal. Okay, but what is the problem with the EEPROM? The problem in the EEPROM that 1 byte of data at a time. This is the problem. What is the solution? Solution it comes in the form of Flash-ROM, where you can write 512 bytes
Sure.
of data at a time. So it is faster in comparison to your EPROM. EEPROM, sorry. So you get the idea. So in the PROM, just write once.
Yes, sir.
Okay, you can't repeat this process again. Once you write, it's just done. What is in then comes EPROM. What is in the EPROM? You can erase and write and repeat this process again and again. But to erasing anything from the EPROM, you need UV light. Okay, getting the UV light is a difficult thing. Solution comes in the form of EEPROM. You can erase and write any amount of the time, but you need just the electrical signals. Here, only 1 byte of data can be written at a time. This is the problem. 1 byte of data at a time. That makes the EEPROM slow. Solutions come in the form of Flash-ROM, where you can write 512 bytes of data at a time. Okay. Any questions?
Yes, sir. No, straightforward.
So let me move to the next one. So this is the storage hierarchy in a computer system. I already explained why this storage hierarchy requires. So as you move from this point to this top point, the cost to store, cost or price in terms of money, okay, to store 1 byte of data is increased. Okay, so to store 1 byte in register and to store 1 byte in your hard disk, the cost here, the price is here much more. Okay,
Yes,
but
sir.
price is higher as you move up. Speed is also high as you move. Register is much faster in comparison to your hard disk. Okay, but the size is decreasing as you move up. This size is decreasing. Okay, size is decreasing,
Mm.
and as you go down, size is increasing. And this size means both
Increase.
physical size as well as your capacity to store the things. Okay, so at the top level of the hierarchy,
Yes, sir.
you have the faster memory, whose speed is high, price is also high to store 1 byte of data. Its physical size is very small and its capacity is also small. So what is the top most of the memory? That is registers, and then your cache memory,
Register.
L1, L2, L3 cache, and all these four things.
L2.
This all the four things up to this point. These things, these are example of static random access memory. Okay,
L.
and then comes your
US.
main memory.
DRAM.
Then comes your main memory, that is dynamic RAM. Okay, dynamic RAM, and this total part is known as the primary memory up to the main memory. This is known as the primary memory. Okay, this is the primary memory.
Yes, sir.
Okay, after here, this is secondary memory, your hard disk, and then other devices. Okay, please remember here that size is here. Size of the register is 16, 32, or 64 bit. Okay, size of L1 cache is 2 MB from here to up to 16 MB. I'm just giving you the idea. It's not an exact number because for different system it may be different. But this registers is after size 16 to 32 to 64 bit, means just 8 byte. If I take the 64 bit, size of the cache is from some KB, 64 KB or MB to 16 MB. That is the size of your cache memory. What is the size of main memory?
DRAM.
It's around 4 gigabyte, 4 to 32. Okay.
32.
And what is the size of the secondary memory? It's in terabyte. It's in terabyte or around 1000 gigabytes. Okay.
Yes, sir.
This chip, this main memory, it comes in around what you can say. Uh, it's in terms of 3000. It's terms of around 6000 in currency of Ghanese dollar. It's around maximum 600 Ghanese dollar gives you around 4 gigabyte of RAM. Okay, and this same amount give you 1000 gigabyte of your hard disk. Same amount. If you just expend 6000 Ghanese dollar, you can get 1000 gigabyte of hard disk or 4 gigabyte of RAM chip. So this is the difference between the price. When I'm saying this, the difference of the price. Okay, so if the cost of this is high per bit or per byte, okay, and this is much cheaper. Okay.
Mm-hmm.
Any question?
No, straightforward.
Okay.
Because
So
registers being basically the fastest and the most expensive. And wait, so what about remote secondary storage, sir?
I'm coming in. This is network device, like in cloud, in your Google Drive, you store something. So it basically,
Oh,
so it just,
alright.
okay, it just depend on your internet speed there. Okay. So as fast as you have your internet connections, that's the speed. So here in this case, remotely, this remote, this is just depend on based on your internet speed. Okay. So here the internet speed matters. Okay.
Yes, sir.
Any questions up to this point?
No,
Okay.
it's
So
alright.
I start here today morning at 9. Do you have any work, or we can schedule the class?
No.